Hello everyone. Today we are moving for the next topic in your greedy technique, that is dijkstras algorithm. Okay, this is very important. Here we call this dijkstras algorithm as a single source shortest path algorithm. I'll just tell you why we'll tell this dijkstras algorithm as a single source shortest path algorithm, because in dijkstras algorithm, in the graph, in the given graph, any one vertex, any one, you can choose 1, 2, 3, 4, 5, anything, any vertex as a source vertex, and from that source vertex you have to find the shortest path to other vertices. So we call this dijkstras algorithm as a single source shortest path algorithm. Okay, here for a given vertex we call as a source, and it should be a weighted connected graph. I'll just show you how this dijkstras algorithm is going to work. See, for example, I'll take 1 as a source vertex. Okay, I'll just select source is equals to 1. So source is equals to 1 means from this vertex you have to find the shortest path for 2, 3, 4 and 5. See how means from 1 to 2 you have to find out the shortest path. From 1 to 3 you have to find out the shortest path. From 1 to 4, then from 1 to 5 you have to find out the shortest path. See here, from 1 to 2, how many paths you have? 1 to 2, there is a direct path, or you can come from 1 to 4 or 4 to 2 you can go, or 1 to 4, 4 to 3, 3 to 2 you can go, or 1 to 4, 4 to 5, 5 to 3, 3 to 2 you can go. See, among these, which is the minimum, which is having the minimum cost? See, from 1 to 2, the cost is 3. From 1 to 2 through 4, 1 to 4, 4 to 2, it is 9. This is heavy. So, even this is also high. Even 1 to 4, 4 to 3, 3 to 2, 7 plus 5, 12, 12 plus 4, it is 16. So, this is high. So, direct path 1 to 2 is there. I will just select 1 to 2. The minimum cost is 3. In the same way, from 1 to 3. Here also you have 3 paths. 1 to 2, 2 to 3, or 1 to 4, 4 to 3, or 1 to 4, 4 to 5, 5 to 3. See, this one you count 1 to 2, 2 to 3. 4 plus 3 plus 4, it is 7. Next, 1 to 4, it is 7. 7 plus 5, it is 12. Or else 7 plus 2 plus 4. 9 plus 4, it is 13. Or this path, even this is also more. From 1 to 3, which path you will take? 1 to 2, 2 to 3. That is 4 plus 3, it is 7. In the same way, 1 to 4, you have a direct connection. The cost is 7, but you have to check with other also. See, 1 to 2, 2 to 4, it is only 5. 5 is less than 7. Okay, or else you can come from 1 to 2, 2 to 3, 3 to 4, but the cost is more. Okay, so here, even though it is having a direct path, but the cost is more. So you have to come from 1 to 2, 2 to 4. Minimum path cost is 5. In the same way, 1 to 5. Okay, 1 to 5, 1 to 4, 4 to 5. That is 7 plus 4, it is 11. Okay, if I come like this, 1 to 2, it is 3. 3 to 4, it is 2. 5. 5 plus 4, it is 9. 9 is less. Is it not? So if I come like this, 1 to 2, 3. 3 plus 4, 7, 7 plus 6, it is more. Okay, so which is the minimum cost here now? 3 plus 2, 5, 5 plus 4, 9. So this is the minimum cost. This is your dijkstras algorithm, finding the shortest path from the source vertex. So here only one vertex will select as a source vertex. So the name single source shortest path algorithm. Select any one vertex as a source vertex, and from this source vertex you have to find out the path. For all other vertices, that path should be of minimum cost. Okay, this is your dijkstras algorithm. Now we'll see the algorithm for dijkstras. As you can see, this is the algorithm for dijkstras. See, first implements single source shortest path using greedy approach. Then input a weighted connected graph. It is a weighted connected graph with non-negative weights. It will not work for negative weights. All the weights should be positive always. Okay, what should be the output? The length d of v of shortest path from S to V. S is the source and V is the vertex. Okay, d of v means it is the weight of that particular vortex. So for I is equals to 0 to v minus 1. Why we are taking v minus 1? Because one vertex, any one vertex will select as a source vertex. You have to leave that, and then until v minus 1 we have to do. So I is equals to 0 to v minus 1. D of I is equals to C of S comma I, means the source vertex. Source vertex you have to just assign. For I is equals to 1 to v minus 1, do find u and d of u. What do you mean by u and what do you mean by d of u? U means the next vertex from the source vertex. D of u means the weight of that vertex. For example, if you go from 1 is the source vertex, if you are going from 1 to 2, the weight is 3, means here 2 is u and 3 is d of u. Okay, such that d of u is minimum. You have to make sure that d of u, the weight of that particular vertex, is minimum. If it is minimum, then add u to s. Okay, for every v in v minus s, do by using this formula you have to find out which is having the minimum weight. Means v means these are the visited vertices, v minus s means these are the unvisited vertices. Okay, for every v in unvisited vertices you have to find out the minimum cost. D of v, using this formula we have to find out the minimum cost. Okay, I'll take the problem, then you'll come to know how you have to just do this. Yes, this is the graph I have taken to solve your dijkstras algorithm. Okay, so 1 to 2, 2 to 3, 4, 5. Source vertex, I'm taking it as 2. 2 is the source vertex. Before going for the problem, first I'll just show you how you have to construct the adjacency matrix, because many of you have confusion in constructing adjacency matrix. In order to construct the adjacency matrix, first you have to just write 1, 2, 3, 4, 5. There are 5 vertex, so 5 cross 5. 1, 2, 3, 4, 5. Because for your lab programs, you have to give adjacency matrix as the input. You cannot give graph. Okay, 1 to 1. In this dijkstras always the self loop will be considered as 0. 1 to 1 it is 0. 1 to 2, what is the weight? It is 2. I'll just write 2. 1 to 3, it is 3. Then 1 to 4, there is a direct path, it is 6. 1 to 5, there is no direct path, I'll take it as infinity. Then again from 2 to 1, it is 2. 2 to 2, it is 0. 2 to 3, it is 1. 2 to 4, there is no direct path, it is infinity. 2 to 5, it is 2. Next from 3. 3 to 1, there is a direct path, it is 3. 3 to 2, it is 1. 3 to 3, it is 0. 3 to 4, it is 4. Again 3 to 5 direct path, it is 4. Next 4. 4 to 1, it is 6. 4 to 2, no direct path, infinity. 4 to 3, it is 4. 4 to 5, 4 to 4, it is 0. 4 to 5, it is 5. Then from 5 to 1, no direct path, it is infinity. 5 to 2, it is 2. 5 to 3, it is 4. 5 to 4, it is 5. 5 to 5, it is 0. This is the adjacency matrix. This one you have to give as an input for your program if you are executing this. Okay, yes. Now we'll move on to the problem. See, I have just taken a table. Yes, okay, this is the source vertex or the visited vertices, you can say. V is equals to V minus S. These are the unvisited vertices, and this is the formula to find out the minimum path among the unvisited vertices. U is the vertex and D of U is the corresponding weight. Okay, now let me start with the problem. See here, first I'll just take here source vertex. I have taken it as 2. So this is, how many vertices are there? 1, 2, 3, 4 and then 5. Okay. From 2 to 1, is there any path? Yes. The weight is what? 2. Just write down that. 2 to 2 it is 0. From 2 to 3 it is 1. From 2 to 4 it is infinity. From 2 to 5 it is 2. See here, in this first step, I am not just going to calculate with respect to the formula, directly I'll write. So before that, unvisited bodies is only source vertex is visited in this step. 2 is visited. Other than that, 1, 3, 4, 5 are unvisited bodies as I'll consider. In the first step, because first you have to get one more vertex, so I am not going with respect to this formula. Directly I'll write, see here, 2, 1 and 2. Among this, which is minimum? 1 is minimum. With respect to which vertex? 3. With respect to vertex 3, weight is 1. Okay, from 2 to 3, weight is 1. See, from 2 you have a path to 3 through 1 also, but this is 5, this is 6, directly it is 1. So 2 to 3 it is 1 I have taken. Yes. And the next step, what do you have to do? Here, I'll just write this as it is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, the same thing. 2, 0, 1, infinity, 2. Here we have taken one more visited vertex, 3. So unvisited vertices are 1, 4 and 5. Now you have to check from 2 to 1, 2 to 4, 2 to 5, which is minimum. First that you have to take. For this I'll use the formula d of v. Here v means it is 1, 4 and 5. First I'll take d of 1. V is equals to 1 I'll take. D of 1 is equals to minimum of d of v. Okay. What is d of v? D of v means the weight with respect to this one, which is source vertex, 2 is source vertex. From 2 to 1, what is the weight? These are all d of v's. These are v's. Okay, d of v means it is 2, because here v value I am taking 1. D of v is 2. 2 comma d of u. What is d of u? It is 1. Already we have calculated in the previous step. D of u is 1. Plus C of uv. For this particular step, C of uv. What is the value of u? It is 3. What is the value of v? It is 1. So C of 3 to 1. What is the meaning of this? From 3 to 1, what is the weight that you have to take? From 3 to 1, what is the weight? It is 3. So C of uv is 3. Okay, so you'll get it as 2, 4. Which is minimum among 2 and 4? Min of 2, 4. 2 is minimum. So I'll just take this one. In the same way, for 4 and 5 you have to calculate. Now, the V value is 4. So I'll take D of 4. Okay, then min D of V. What is the weight here? Infinity. I'll just take it as infinity only. Then D of U. What is D of U? It is 1 itself. Plus C of UV. Here C of U remains same. It is 3. What is V? It is 4. Now it is C of 3, 4. From 3 to 4. What is the weight from 3 to 4? It is 4. So 1 plus 4 I will take. What you will get? Infinity, 5 you will get. Okay. Infinity, 5. Which is minimum? 5 is minimum. I'll take this. Next, V value is 5. I will take D of 5. D of 5 is equals to min D of V. What is the weight of 5? It is 2. D of U, it is 1 itself. It is not changed. Plus C of UV. U value will not change. C of 3. V value is now 5. So C of 3, 5. 3 to 5. What is the weight? 4. So 2, 5. Two, 5, which is minimum. 2 is minimum. So here d of 1 is also 1. Okay, from 2 to 1, and then d of 5 is also 2, d of 1 is also 2. According to the order, I'll take first d of 1 is equals to 2. What is the meaning of this d of 1 is equals to 2? I have to take from 2 to 1, the weight is 2. 2 to 1. The next vertex I'm taking is 1. Weight is what? 2. You just check here. 2 to 1. It is 2. I have just checked through all the things. From 2 to 3 I have checked. 2 to 3, 3 to 4 I have checked. 2 to 5 I have checked. But this is minimum. 2 to 1 direct connection is minimum. So I have taken 1, 2. 2 to 1, the weight is 2. Now in the next step, while writing this one, you have to update the values. 1, 2, 3, 4. Yes, see here. 1, it is already done. 2, 2 to 2, it is 0. 2 to 3, it is 1. And d of 4, that is 2 to 4, I have calculated it as 5 in this step. So instead of this infinity, you have to update this as 5. Here 5 is 2. Here also it is 2. I'll just take it as 2. So now here 1 is also visited. Unvisited vertices are 4, 5. Now you have to repeat the same thing. What you have to do? D of V. V value is 4 and 5 now. I'll take D of 4 is equals to min D of V. 4. What is the value of 4 now? It is 5. Comma. What is D of U? D of U is 2 now. A previous step value you have to take 2. Plus C of UV. U value is 1. V value is 4. 1 to 4. From 1 to 4, what is the cost? 6 is the cost. So I'll take 6. This is 5, 8, which is minimum. 5 is minimum. I'll just take 5. Okay. Next. D of 5. D of 5 min D of 5. What is the value? Sorry, this is 5. So here it is 2, comma D of U. It is 2 only. C of UV 1, 5. From 1 to 5. There is no direct path. It is infinity. So 2 plus infinity is infinity, which is minimum. 2 is minimum. So this is minimum. Among 5 and 2, this is minimum. So which is the next path, next vertex I am taking? 5. 5 and the cost is 2. I'll take 5, 2. From 2 to 5, it is 2. See here, from 2 to 5, it is 2. From 3, it is 5. It will become 5. From here, it will become 9. So direct 2. This is the minimum. Then I'll go for the next step. 1, it is 2 only. 2, it is 0. 3, it is 1. 4, here also I have got 4. 5, I'll write 5. 5, it is 2. Now 5 is also visited. So 4 is the unvisited vertex. Only 1. So D of 4. Min, what is D of V? 5, comma, what is D of U? D of U is 2 plus C of UV. U value is 5, V value is 4. 5, 4. 5, 4 is 5. So this is 5, 7. But which is minimum? 5 is minimum. Okay. So here only 1. From 2 to 4, the vertex is 5. The weight is 5. 2 to 4. See here, from here if I come it is 8, from here it is 7, from directly it is 5. So I have got 4 comma 5. Now you have to just write all the things from 2 to 1. Here you can see 2 to 1, the weight is 2. 2 to 2 you live. From 2 to 3, weight is 1. Okay, from 2 to 4, weight is 5. From 2 to 5, the weight is 2. This is directly from 2 to 1. This is directly from 2 to 3. This is from 2 to 3, 3 to 4, and this is directly 2 to 5. This is how you will just find out the minimum path from single vertex source. This is the source from 2 to 1, 2 to 3 to find out the shortest paths. Okay, this is